This video is sponsored by Manscaped, which wants to take care not only of beauty, but also the health of all men. I'll tell you more about this unique campaign at the end of the video. October the 25th, 2005 was marked by a tragedy in the Large Hadron Collider. During a routine equipment installation in one of the tunnels, a huge switchgear cabinet weighing over a ton slipped on its support and crushed forklift truck driver Jose Pereira Lajes. It was a terrible accident, but considering that the construction of the Large Hadron Collider took 10 years, from 1998 to 2008, and employed tens of thousands of workers, just one death is an incredible statistic, especially if we consider the amazing scientific discoveries made with the LHC. But what's bothering me is, what if we're yet to pay the real price of using the world's most powerful particle accelerator? Could it harbor a black hole or some other extreme substance that could destroy the Earth? Or maybe what's at stake here is the very existence of the universe as we know it. As physicists are now seeking funding to build an even more powerful collider, I decided to find out if the Large Hadron Collider could cause the end of the world. Why do some scientists believe the LHC could create a black hole and destroy the Earth? CERN, or the European Organization for Nuclear Research, didn't plan the giant particle accelerator to be anything like an extreme object generator. Scientists had completed the standard model of particle physics, but it needed to be confirmed in practice. In 1968, Stanford linear accelerator experiments clearly showed that the proton consists of three tiny point particles, quarks, just like the neutron. Based on this observation, they were classified as hadrons. But then the physicists hit a wall. A thorough study of quarks themselves required something much more powerful than the 3-ish kilometer long Stanford accelerator. So CERN started looking into creating a monstrosity, the Large Hadron Collider, which would cost $9 billion. Its tunnel has 27 kilometers in circumference, which makes it 9 times larger than the Stanford accelerator. Inside it, there are around 10,000 magnets kept in a superconducting state at around 2 degrees above absolute zero, which requires 96 tons of helium-based coolant. All of this is done to accelerate beams of protons to just short of the speed of light and hold them together. At such parameters, they collide with a minimum energy of 7 tera-electron volts, which is 140 times more powerful than the Stanford accelerator. I spent a lot of time searching for an apt comparison to help me understand how much it really is. Technically, 7 tera-electron volts is millions of times less than you spend to bring a cup of coffee up to your lips. But both the hand you're holding it with and the cup itself are made up of atoms with trillions of hadrons, while in the LHC, the same energy is applied to separate beams of protons. If you scaled it up, it would be more similar to a head-on collision of supersonic jets. But how does this all help particle physics, and what do black holes have to do with it? The Large Hadron Collider's main purpose is to break up protons and carefully study their parts in search of anything out of the ordinary. To continue with the supersonic jet analogy, it's as if we tried to figure out how their engines were built and what their fuel was comprised of by looking at the scattered remains after the accident. But when they started drilling the first tunnels for the future collider near Geneva in 1998, some scientists voiced their concerns that these collisions might have very unpleasant side effects. Renowned British astrophysicist Martin Rees theorized that the Large Hadron Collider could generate quantum black holes. This would not be because of the accumulation of mass, which is how usual black holes form. It would be a high concentration of energy energy in a space that's small enough. Such microscopic black holes were predicted by Stephen Hawking himself. But CERN was quick to contradict Rees, saying that according to their calculations, the energy with which protons collide in the LHC is quadrillions of times lower than it would take to form a quantum black hole. The Standard Model backs it up, but Rees was citing its not yet disproved alternatives, which suggested even several giga-electron volts would be enough for an apocalypse. The media described it all too vividly. A quantum black hole springs up near Geneva to devour all of Europe in mere seconds. And a minute later, there's a standard black hole where Earth used to be, and it's only 3 centimeters in diameter. Spoiler alert, none of that actually happened. But it's not the fact that Martin Rees was utterly wrong. You see, one theory holds that a quantum black hole can't suck anything in. Quite the contrary, it's supposed to evaporate instantly and release a powerful wave of Hawking radiation. Incidentally, during a series of preliminary tests on September 19, 2008, 100 magnets in the Large Hadron Collider overheated simultaneously, which led to a large leak of 6 tons of helium coolant. Luckily, it only affected the magnets themselves and staff weren't injured. But maintenance ran overtime, and the launch of the LHC had to be postponed by more than a year. So, could the accident have happened because a microscopic black hole exploded? Most likely no. Since the launch of the collider in 2010, nothing like that has happened again. Well, either that or CERN physicists have covered up the creation of quantum black holes to keep panic at bay while taking precautions to save the equipment. That might have explained the drawn-out maintenance. I, for one, am wary of such conspiracy theories and would prefer to cross all the T's and dot all the I's in the matter of the LHC's safety, except that black holes are by far not the most terrible things it could do. One of the purposes of the Large Hadron Collider experiments is to recreate the conditions of the Big Bang on Earth. You heard me right. This is the bang our universe emerged from. Is it just me, or does it really sound like a recipe for potential catastrophe? Physicists theorize that within the first 10 microseconds after the Big Bang, the universe didn't yet have its usual matter of protons and neutrons. Instead, it was filled with quark-gluon plasma that was trillions of degrees hot. Essentially, it was a soup of subatomic particles 100,000 times hotter than the sun's core. It's this extreme substance that scientists decided to recreate in a series of Large Hadron Collider experiments called ALICE. Going down this rabbit hole involved acceleration to the speed of light, but this time, instead of the usual proton beams, they accelerated giant lead atom nuclei containing over 200 hadrons each. I can't even compare this to a supersonic jet collision. It's more like an impact a small asteroid would have if it hit their runway. The lead smashing started on November the 8th, 2010, and as soon as May of the following year, the ALICE team announced that quark-gluon plasma was successfully synthesized. The experiment was repeated again and again, and it was playing with fire. Because in the modern universe, quark-gluon plasma can only exist in ultra-dense neutron star cores. If just one drop of quark-gluon plasma from there ended up in a laboratory on Earth, it would lead to an explosion much more powerful than the detonation of all nuclear weapons together. As a matter of fact, the synthesis of quark-gluon plasma in the LHC did cause huge energy bursts, that is, relative to a few atoms. Because extreme temperatures and pressures comparable to those in a neutron star core weren't maintained, quark-gluon plasma quickly expanded and cooled, reassembling into hadron cascades. So, while it may be the most extravagant way to remelt lead, luckily for us, it's no catalyst for the Big Bang on Earth. Although, besides quark-gluon plasma, the LHC collisions can also bring back another extreme property of the early universe, which is actually capable of shredding us into atoms. I keep reminding you that our universe started with the Big Bang, but what I don't tell you is that the Bang itself wasn't the reason why it's so immense. The Big Bang had a sequel known only among cosmologists. According to their theories, in around 10 to the minus 36 seconds after it began expanding, the universe was even smaller than protons and quarks, and if it had gone on at the same pace, we would have been highly unlikely to have built the Large Hadron Collider because the universe would have still been too dense and hot for any life forms. We were saved by cosmic inflation. For some reason, right after the Big Bang, the subatomic universe swelled up to the size of a coin. This might not sound like too much, but in truth, it's the difference between a grapefruit and all the universe observable today. And though inflation broke off in 10 to the minus 32 seconds after the Big Bang, it was enough to give impetus to the young universe and not let it condense under its own gravity back to the size of a point. Only there's the rub. Scientists have no idea what caused this inflation. One theory is that it must have been a special inflation field with a particle called the inflaton. At the moment of the Big Bang, there was so much energy that the field was very quick to charge that particle, and the universe ballooned as a side effect. Put simply, it was as if the inflaton went down an energy slide and then disintegrated. One theory is that those were the fragments of inflatons from which quark-gluon plasma emerged, but it also means that if we pump it full of energy, we may turn back time and resurrect the inflaton. Anyone who can make that happen in the Large Hadron Collider is a sure winner of the Nobel Prize in Physics, and a sure goner, too. You know, with its life back, the inflaton is gonna want to have some fun, just like in the good old days at the dawn of the universe. It'll go down its energy slide again, instantly inflating the surrounding universe. This means that lots of new space will appear underground near Geneva, like the size of the Earth or even the entire solar system. Needless to say, such an inflation bomb will rip our planet to pieces. Today, scientists at CERN claim there's no way their project could bring the inflaton field back to life. The best, or worse, the LHC could generate is the inflation in one of the lower sections of its energy slide, meaning space expansion won't be that extreme. This optimistic guesstimate has only one thing that bothers me. To this day, the exact parameters of the inflation field remain unknown. What if it was so powerful that even at the end of its existence, it could, if not destroy the Earth, then at least leave an enormous crater where Europe is now? Consider me superstitious, but I'd rather they had no Nobel Prize but left the Earth intact. Besides, CERN physicists have already won it for discovering another incredible particle with no less dangerous capabilities. The Large Hadron Collider gifted us with the elusive God particle, but could any of its further studies lead to a universe-wide disaster? The particle was first mentioned by British theoretical physicist Peter Higgs in 1964. Back then, scientists were desperate to solve a rather sophisticated riddle. How do some particles acquire mass? And it's not about hadrons in our atoms. Their mass is generated from the energy of quarks and gluons buzzing inside. But how come mass is also a property of bosons, responsible for the weak interaction and radioactive decay of atoms? That was a total mystery. Peter Higgs assumed that when moving, these particles experience the resistance of an unknown field that permeates the entire universe. It's like walking on the bottom of shallow water. The deeper you go, the harder it is to lift your legs with each step. Higgs' bold idea found support among other scientists, who jokingly gave the godly nickname to both the field and the particle. Eventually, the Higgs boson fit into the standard model so well that generating it in an experiment became a point of honor and reputation for all physicists. The Large Hadron Collider became the first ever accelerator which allowed colliding protons with enough force to shape the Higgs field and set off ripples of God particles. And on July 4th, 2012, two CERN teams simultaneously announced they had found the Higgs boson. It turned out to be amazingly massive, being around 130 times heavier than protons. This means the Higgs field has abnormally high energy, even in its steady state, without any external charging. It's as if you turn off your Wi-Fi router at home but remain connected to the web. It's impossible, but that's what happens with the Higgs field, except it provides not the Wi-Fi signal, but mass to particles everywhere in the universe, all at once. It reaches even the emptiest spaces between galaxies, a godly field indeed, albeit with one terrible effect. The existence of the massive Higgs boson means that our universe's vacuum is not true. It's false. In other words, even the darkest and emptiest parts of space are bursting with background energy. And that makes our experiments in the Large Hadron Collider extremely dangerous for the entire universe. Remember the inflaton and its energy slide? Nothing stopped it on its way down, where it changed the look of our universe forever. Right after the Big Bang, the Higgs field also started from the top of its own slide, but was stopped by an obstacle. Physicists believe that the Higgs field encountered a local minimum on its way down, which is something like a trough on a hillside. Since then, its bosons have been stuck in it, unable to get rid of all their energy. This rather fortunate occurrence gave some bosons mass, which in turn made the laws of physics work as they do so that matter and we ourselves could exist. But there is a risk that the Higgs field could get out of this jam. In a roulette game, a ball that has already landed in a cell can bounce if you hit the table hard enough. And if somewhere in the universe the Higgs boson experiences a similar energy push, it'll be able to finally slide down to the bottom of the hill, giving away all its energy. And that would be enough for the entire Higgs field to follow it down to zero. Scientists refer to this chain reaction as vacuum decay, and it's an apocalyptic spectacle. A wave of true vacuum will spread in all directions at the speed of light, destroying the very fundamentals of our physics. While protons and neutrons won't lose their mass, the interactions between atoms themselves will change so drastically that it won't be possible for matter to exist as it is. Everything in our existence will disintegrate, releasing a tremendous amount of energy and turning all planets, stars, and entire galaxies into no more than handfuls of subatomic particles and radiation, and there won't be a single way to stop this vacuum apocalypse. What we could do, though, is set it off right in the Large Hadron Collider. One day, a collision of a proton beam may shake the Higgs field so hard that its boson will slide into a state of zero energy and start a chain reaction throughout the universe. Of course, CERN rules out this scenario as extremely unlikely, but this is hardly any consolation for me. Do you have any idea how many collisions of protons happen in the Large Hadron Collider every day? 100? 1,000? 1,000,000? Hold on to your hat. In 2016, after a 2-year gap for technical upgrades, scientists at CERN reported a record amount of proton collisions at 1 billion per second. On top of that, the improved collider now operates at an energy of 13 tera-electron volts, which is almost twice as much as its initial capacity. What this means is that a day of the LHC's continuous operation results in over 86,400 billion high-energy collisions, each creating an opportunity for the Higgs boson to get out of its trough. But the vacuum disaster still hasn't happened, so its probability is extremely low anyway. Is that what you think? Well, if you flip a coin long enough, sooner or later, instead of heads or tails, it'll land on its edge. And if such an incredible scenario is possible, it opens the floodgates for the most extraordinary threats that CERN dismisses as fantastical. Maybe they shouldn't. there's a possibility that Large Hadron Collider experiments will transform Earth or even entire worlds, and we just got confirmation that it can happen. A few days before Halloween of 2022, astronomers announced an incredible discovery. 10,000 light-years from Earth, an anomalously light neutron star was discovered at the site of a supernova. All our knowledge about these objects says that this is impossible. The only possible explanation so far has been that we have found a strange star. Yes, literally. Scientists have long assumed that in certain conditions, quarks can form not protons and neutrons, but another stable substance, strange matter. It remains in a state of maximum density and minimum energy. Of course, such an exotic substance excites the minds of scientists at CERN, who've long wanted to create it in the Large Hadron Collider. But British physicist Martin Rees, whom you might remember, is very vocal against attempting it. You see, unlike with quark gluon plasma, strange matter isn't necessarily bound to disintegrate. Instead, it forms so-called strangelets. These are whole fragments of quark substance which can be literally contagious. Just as one Higgs boson starts a chain reaction in the entire field when it bounces off its trough, a strangelet can sort of teach the surrounding matter to be just as energy-saving and dense. Rees is concerned that if such an epidemic begins in the LHC, it'll take it mere minutes to turn Earth into a strange planet just 100 meters in diameter. And before you follow CERN's suit and cite the improbability of such a scenario, I want to let you know that strange stars were also considered impossible for a long time. But perhaps the most exotic theory about the threats of the Large Hadron Collider is the one in which a global catastrophe has already occurred, and we barely survived it. This guy's name is Max Laughlin, and he looks no older than 15. Anyway, his fans call him one of the smartest teenagers on the planet. The founder of a high-tech startup, Laughlin also demonstrates deep knowledge of physics. And according to his hypothesis, the Large Hadron Collider experiments have already brought about a global cataclysm that affected all of us. Whether it was a vacuum decay or a plasma explosion doesn't make too much of a difference. What matters here is that the survivors of this disaster were transported to a neighboring parallel universe without even noticing it, but only for a time. It's the Large Hadron Collider that Max Laughlin blames for the so-called Mandela effect. When the rights activist and former South African President Nelson Mandela passed away on December the 5th, 2013, it turned out that thousands of people across the globe thought he was long dead. They were convinced he died in prison in the 80s and never got to be president. It might have been explained by mass hallucination, but today the Mandela effect has spread to a whole bunch of things, influencing people around the world. Some claim that the mascot of the Monopoly game has always donned a monocle, even though he never has. Others are certain that in the first Star Wars sequel, Darth Vader says, "Luke, I am your father." No such line is in the movie. There are dozens, if not hundreds, of examples of the Mandela effect, and it's likely that you've experienced it too. Moreover, this theory fits in with the so-called many worlds interpretation of quantum physics, where each scientific experiment creates new universes. So, are Mark Laughlin's theories really that far-fetched? What if the Large Hadron Collider did split our universe, randomly throwing us into its parallel reflections, especially considering that the Mandela effect manifested for the first time a few years after the first protons collided in the LHC? Hold on, what was that guy's name? Max or Mark? Anyway, CERN is not just bent on continuing experiments in the Large Hadron Collider, it's going to build a new one. The Future Circular Collider is a truly grand project. Its circumference of 100 kilometers will allow colliding particles at an energy of 100 tera-electron-volts, 6 times the current figure. All that's left is to find $22 billion, and the Future Circular Collider will have been built by 2050 at the latest. The purpose of it all is to make testing physical theories more thorough. But I'm stuck on the feeling that when we test them, we also test our luck and the universe at large. What about you? But there are some essential life spheres where you shouldn't rely on luck. I'm talking about your health. Did you know that every hour of every day, one man on the planet is diagnosed with a severe form of testicular cancer? But the whole excruciating process of treatment can be avoided. That's why Manscaped, in partnership with the Testicular Cancer Society, wants to remind all men to have regular screenings for this cancer type. And the simplest check can be carried out on your own with an easy once-a-month routine at home, right at the moment when you use Manscaped products to take care of the appearance of that region below your waist. On the manufacturer's website, you can find detailed step-by-step instructions on what exactly needs to be done, and I highly recommend studying it carefully. And while you're there, you can use my promo code Ridddle with 3 Ds to get a 20% discount and free shipping. For example, to order the special limited edition TCS Lawnmower 4.0 trimmer. If you want to learn more and join the campaign, visit the organization's website. Join the Manscaped movement, and don't forget to take care of your pair.